So I'm going to show you several different features of VS Code that can help you be much, much more efficient when you're debugging. When you start programming, like the most common way that you debug, well, I guess the most common way is to randomly make changes and run it again and hope that it gets better. Um, you've all moved beyond that, which is great. Um, and maybe you've started doing like you might have started with a lot of like print statements like in Python or system out print lines in Java, and then you look at the output to help you debug. The debugger, as you saw last year with BlueJ, is so much more effective. The debugger built into VS Code is at like a whole nother level in terms of what it can do. So I want to show you and demonstrate for you a few of the VS Code advanced debugging features, because as you start working on more and more complicated code, these are going to be more and more useful for you. So the first one I want to show you is I'm going to set a break. So I'm going to show you like how to set breakpoints first of all. So I'm going to set a breakpoint here on line 16. If I hover my cursor over, make this easier for you to see. If I hover my cursor over to the left of the line number, you can see there's this little red dot that pops up. That's what I click to add a breakpoint. Okay, so that's how I add in a breakpoint to my code. Now, if I run Sudoku here, oh, just kidding. Now, if I debug Sudoku, so I can click on the arrow here and hit debug Java, or over here, I can click on the debugging button in the menu, the sidebar, and hit run and debug. So if I hit run and debug, it pauses at line 16. You'll notice a couple of things. The line of code that is about to execute is highlighted in yellow. You'll notice that this little window popped up here with these buttons. This button that looks like a play icon, like on a, I don't know, like a video player, continues. It just keeps running code until the next breakpoint is hit. This icon steps over the line of code. I mean, it executes it and goes to the next line of code. This button, the down pointing arrow, will execute the line of code and step into any methods that line of code invokes. In this case, it would step into the file constructor. And if I kept pressing it, it would eventually step into the scanner constructor. This line of code steps out of the current method into whichever method called it. I can restart my program. I can stop my program. We're not going to worry about the last one today. You'll also notice there are annotations. This is really handy. So I can see the value of the variable file name because it just shows up on this line of code here and up here. I can also see that over here in the left pane where I can see all of my variables and their current values. Some of these I can click to open up, and then I can see like all the instance variables, for example. We'll get to some of these other things later. But what I can do, this is a new thing I can do, is so I've opened up this, and if I look for squares, here's squares, I can right click on squares and I can say break on value change. What that means is that whenever the squares instance variable's value is changed, the code will stop. This is really valuable because sometimes you have a bug where things look good and then later your code crashes or doesn't work because the value has changed and you have no idea where. Maybe you had a bug where like you were getting a null pointer exception because squares was somehow became null, but you know it wasn't null at some point, so something changed it to null. How do you figure that out, right? It could be really tedious, or you can right click and say break on value changed. And then if I run this, I hit a breakpoint here at line 70. I didn't set a breakpoint at line 70. The code paused at line 70 because this is where the value of squares is going to be changed. So if I step over this line of code, we can see that squares is now no longer null. The value has been changed. Huge efficiency when it comes to debugging to be able to break when a value of a variable is changed. All right, let me show you another example. I can set a breakpoint here at line 77, where I'm checking like this. I'm iterating through all the rows and all the columns, right? I don't know what I'm doing here. I'm populating all the squares, right? And I know that something goes wrong, but it doesn't go wrong until I get to row 3, column 4. And either I can step through this code like, how many times is that? 27, like 31 times, or I can set a conditional breakpoint. So all my breakpoints are listed down here. And these are the line numbers they're set at. So here's my breakpoint at line 77. I can click on the pencil icon, and then I can edit the condition. So I can type any expression here, and when the expression is true, the code will pause. And when the expression is false, the code keeps running. So I can say something like row equals 3 and column equals 4 and hit enter. And now if I run this code, I've paused here, but it went through this line of code, got executed 30 times before I got here. And now when it's paused, I'm on row 3 and column 4. Think of how many times, like in APCSA, you're like step, 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 right? It gets really tedious. Or it's like, the 15th one, and you're like, steps, you're like, go, 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 go. And you click one too many times and you missed it. Now you got to start all over again. Like, this is so much better. So you can set conditional breakpoints based on the value of variables. The other thing you can do is I'm going to set a breakpoint here on line 78, and I'm going to get rid of the 77 one. So I'm going to run to that point. So now I'm about to execute line 78. Sometimes, last year we tended to write a single operation on a line of code. And in a way that makes it easier to debug because we can kind of check step by step. This is kind of tricky here because there's a lot going on here. I'm invoking map cell to square. And then based on the return value of that, I'm getting an element out of the squares array list. And then based on that reference, I'm adding this other, there's just a lot going on here. This is where watch can be really useful. I can click on the plus icon here in the watch pane, and I can add an expression to watch. And this expression can even be calling a function. So I can say this dot map cell. Maybe I suspect that map cell to square isn't quite right. And I could step into it. Or I could just add a watch condition here, row, comma, column, and hit enter. I think I'm going to need to make this a little bit bigger. There we go. So now I can see that for the current value of row and column, row 3, column 5, it returns the value of 4. So without stepping through map cell to square, seeing what the return value is, I can just add a watch expression and be like, oh, 4 is good. This is okay. Okay, let's go check out the next one. Run again. Now I'm at row 3, column 6, and this method returns 5. Is that what I expect? Right? So this watch is super, super helpful. The watch is also super helpful if you have like an instance variable, which is self as a reference to another class, and like you find yourself constantly spinning things open over and over and over again. You can just add it as a watch expression, and it can save you some of that too. But watch expressions are super, super powerful. All right, one more example I want to share with you. So I'm going to get rid of my watch expression, get rid of that breakpoint. I'm going to jump down to line 112. So in line 112, this is where we're actually trying to figure out, we're trying to recursively solve the puzzle. And so maybe I know I've determined that the first 7 times that this runs, everything is good. But the 8th time is when something is wrong. But I'm not quite sure what expression to put there. I just know the 8th time that we find a 0, that's when I want to pause. And I don't remember what the row and column is, but I know it's 8 times. So I can set a breakpoint here on 112. I can edit this breakpoint. And instead of expression, I can change it to hit count. And I can type 8 and hit enter. What this will do when I run now is it won't pause here on the first, second, third, fourth. It will wait until this line of code is executed 8 times, and then it will pause. So if I hit run, when I've stopped here, if I scroll through my output, you can see we've made several steps towards the solution. But now this is the 8th time this line of code has run. So now I can look at like what next row and column are about to be, and move on from there. So it's helpful. So these are all like really useful debugging tips that I hope will save you a ton. Well, no, I know they will save you a ton of time, but you have to invest some effort to like get over the learning curve, right? So you have to have the discipline to be like, I'm not going to randomly change code and run it. I'm not going to add another system.out.println. I'm going to set breakpoints. Boy, this is really tedious as I go continue, continue, continue. Oh, okay, here's where I set a conditional breakpoint. And eventually all of these little features will become second nature to you, and your debugging time will be dramatically decreased. So